Hi everyone, I'm Veronica Rossano. I'm presenting this paper on behalf of my co-authors Federica Mangialardo and Teresa Roselli. We are from the Department of Computer Science at University of Bari in the south of Italy. The motivations of this research paper are in the European Digital Education Action Plan that has defined the key competencies for lifelong learning, and among these key competencies that each citizen of European citizen should have, there are mathematical competencies. So the goal is to combine STEM education. STEM stands for science, technology, engineering, and math, with game-based learning, that is one of the most used approach in education in order to make effective a learning process. And in our case, we have used the serious game, that is a video game with a serious purpose, in order to implement the game-based learning approach. Both literature but also app stores are very there are a lot of examples of games, a serious game applied to math subject, but the novelty of our research paper is stands in the learning content and the adaptation process. The learning content we choose were defined. The learning content was defined on the basis of the educational objectives that students should acquire in the fourth grade of a primary school. So we read carefully our education plan in our primary school, and we choose these 8 problems category that that we have implemented in the serious game. The adaptive process is used in order to change the kind of problem that is presented, that is proposed to the player during the game, according to his competencies. The user skill is the between the number of times that user has correctly answered to a class of problems, the class problems, the category of problems that I mentioned before, and the number of times that the player has encountered problems of that group. So what is the novelty? The novelty of this adaptation process is that the problems change not according to the levels in the game, but according to the skills acquired by the student during the games. So if the student fails more often problems that are related to the commutative properties, for example, in the next levels of the game, the game will propose more often problems of this type. This just to let the student practice more the problems, practice more the exercise in which he has some difficulties, in which he has some lacks. In this way, we would push the student to go in depth in that kind of problem, in that kind of arguments. So Of course, not only that kind of problems will be proposed to the student, because this could be boring or frustrating for the student. Of course, we know that, but with a higher probability, he will encounter it during the game a lot of problems in which he failed often. So this is a short video, a short example of the video game. Of course, each student has a student profile. In this case, he can use the game more often. This is the storytelling of the game, and the player is a witcher that has to help the lord of this world to save the world, of course. And in the duels that he will encounter during the game, he has to solve some mathematical problems. This is an example of the duels, and during the game he can use the spell book, that is a book in which all the rules, all the properties, math properties included in the game are presented. So in this case, the game could be used without the support of a teacher, or without the support of a parents, or a tutor. In this case, when each time that the student need to remind some rules, he can just visualize the spell book and learn something. So in the so we designed a pilot study to measure learning effectiveness, cognitive workload, and user engagement. We involved the sample was composed of 21 pupils of a primary school of Bari, for a fourth grade of a primary school. The procedure was pre-test, educational activity, and post-test and questionnaire. It is most important, is very important to underline that this pilot study was conducted during COVID pandemic. So we have a meeting, online meeting with pupils. We just present the activity, and then they were free to use the game for a week. Of course, we just asked them to complete all the game in order to be able to encounter, to use all the problems, to solve all the problems within the serious game. The questionnaires that we used were the system usability scale, the NASA TLAX questionnaire, and user engagement scale. For what concerning the learning effectiveness, as you can see in this graph, we registered a higher post-test score. Of course, this was the average score in the post-test of the pupils. For what concerning the workload results, the NASA TLAX is a questionnaire that that measures six dimensions, and for each dimension the maximum score is 10. And as you can see, mental demand physical demand, temporal demand, on frustration are were scored very low by pupils. Instead, the highest low score was the how they feel satisfied of the performance in using the application. The same was for user engagement, in which four dimensions were measured, and in this case the maximum score is 5. And as you can see, the pupils feel rewarded by the use of the application. The aesthetic was appreciated, also the perceived usability, and they focused their attention during the game, so they were not distracted by the gaming. For the system usability scale, as you can see, we registered an excellent score. So concluding, the experience was engaging. The mechanics, content, and graphic were appreciated, and the teacher stated that a much more enthusiastic and participative learning climate was they registered an enthusiastic climate during the learning activity. Next step will be improving the student model, because this is very simple student model, to add some hidden mission in order to let the pupil to make the game more challenging, and adding some other learning content. So thanks, gracias, and grazie.